So we're looking at the integral of cotangent to the fourth of x dx, and we know some stuff about cotangent squares, so we change it in terms of that first. And then looking at these two, we know that if we had a combination of cotangents and cosecants, things might work out to our advantage. So change one of them, or maybe even both of them, when you're trying different things, using the Pythagorean identities. So I'm going to go ahead and change one of them using cosecant squared x minus 1. Now that we have a combination of cosecant squares and cotangent squares, we might want to remember derivatives and integrals that relate these two things. So quickly let's write down cosecant x. We know its derivative is minus cosecant x cotangent x, and we know that the derivative of cotangent x is minus cosecant squared x. You just want to remember that because we don't want to confuse things between differentiation and integration when we do our u sub and want to use these to our advantage. Let's look at the integrals as well. So just sort of reversing my order. The integral of cosecant x cotangent x goes to minus cosecant x plus c, of course, and the integral of cosecant squared will pop out a cotangent x. So I want to keep these two things in mind as I'm manipulating these items to create my u and du. So let's think this through. If I let u, I sort of have two options if I want to start doing a u sub right now. If I let u be cosecant x, then its derivative is cosecant cotangent, and I have a cotangent squared, and I also have this minus 1 factor that's going to throw things off a little bit. So let me try the cotangent x, I'm thinking. If I let u be cotangent x, the derivative of cotangent x is cosecant squared x with a minus factor, of course, and I do have that there. Of course, if this minus 1 wasn't there at all, I would be good to go because u would be cotangent x, and then my du would have the factor of cosecant squared. The minus 1 does throw things off a little bit, but if I just separate this into two integrals, maybe things will work out to my advantage. So let's just say deal with the first part, and then when I distribute the cotangent squared x dx, I'll have to deal with this, of course. Again, it doesn't really come from my integral list. If it was a cosecant square, that would be great, I would be done, but it doesn't look like it's on my basic integral list that compares these guys. So I'll deal with that in a little bit, but here we know that we sort of have things under control. We said we're going to let u be cotangent x, and then our du will be minus cosecant squared x dx, and it should take care of that first part. So we're basically going to have cotangent is our u again because we have our du sitting around there. So we're going to have u squared, and then this guy and this guy is going to give me a negative du, it looks like. So what I have is negative u squared du, and that's just negative u cubed over 3, and we'll deal with the plus c at the very end. Of course, I still have this in the back of my mind because I have to deal with that. So I end up with negative cotangent cubed x over 3 for now. Now let's move on to this piece. Of course, there's a minus out in the front to deal with also, and see what we can do here. So when I focus on there, on that piece, I do know that I have cotangents that I can change into having cosecant squares involved as well, using the Pythagorean identities. So this same guy that helped us switch this piece, why don't we apply that again? And kind of thinking ahead, you're thinking, if I apply it again and I have a cosecant squared as an integral, that's pretty good because I know what the integral of cosecant squared x is. So that's motivation to think, I don't know how to work with cotangent squared x dx if it's just an integral by itself, but if I can get a cosecant squared x in there, then I might be in better shape. So for that reason, we're going to go ahead and apply the identity again. And when we do that, if you'd like, we can again look at this as two separate integrals. Again, remember in the back of my mind, I still have to distribute that negative. And so now we're pretty good because we know what that is from our basic list here. That's just going to give me negative cotangent x minus, and that guy is just going to give me x. Don't forget the minus in the front. That's going to give us cotangent x plus x. So I took care of both pieces. Let's put it all together. And we end up with, I'll put the positive term first, cotangent x minus cotangent cubed x over 3 plus x plus c for our final answer. Now, of course, there may be other ways to do this, but this just logically thinking through and starting with, oh, I don't know what to do with a fourth power. Well, squares are more helpful because of this guy. And then squares would be more helpful if I could relate cotangent squared and cosecant squared, because maybe I can make use of these, and then it just kind of took a natural path and worked out okay. You might, if you change both of these to cosecant squared x minus 1 and then multiply that out, you might be even able to go another route with that and do the integral, but this seemed like it wasn't too long and fairly manageable to handle.